For your pre-class homework today, we're really going to focus on going over some basic terms, some of which will be reviewed to you, others of which might not be, but these are going to be key terms for us to use for the whole rest of the semester, and for some of you, you'll be using them for the rest of your graduate career or afterwards. So I want to make sure we're on the same page very early. And some of them we've already actually discussed in class so far this semester. I just want to get definitions out. During this presentation and by the end of this video, you're going to be able to identify and define those key terms. You're going to need those definitions for exams, and really you're going to need them in class. You're going to have to be able to develop different examples. I give you a bunch, and I want you to think about some examples throughout this video and in preparation for the next class. And then make sure that you can develop examples from your own field. So you can see that really key element of like being able to identify the terms, define them, and provide examples. That's really the framework for this whole presentation, is I'm going to give you the terms, provide a number of definitions, and I'll give you some examples, have you generate some as well. You're going to see that you have to do that in class. You're going to see that you're going to do that on exam, the first exam, but you're also going to see that as a part of being able to come up with your own examples and apply it to your field. We have so many different fields in this class. I can't give examples for every single one, but I'm going to encourage you to think about them. Ask me questions if you're not really sure. All right, so let's get into those terms. The first one is a construct, and this one is probably one of the harder terms, but we're not going to spend a ton of time with it because we can't do much with constructs, but they're really important. A construct is an abstract entity, so it's something that we can't see or touch, but we know it exists. It cannot be directly measured. A major distinguishing feature of constructs is that they're indicators they exist, but no one can directly and empirically measure it. So think about the fact that there are plenty of things we can go around and we can measure every day. I can take a ruler and I can measure the length of something. I can put it on a scale and objectively measure the weight of something, but I can't go up to you and say, how anxious are you, and get an objective measurement. And other things like self-confidence, creativity, we can't get those as a direct measurement, put our fingers on it and really get a sense of what it is. But we do have ways to get indicators or proxy information to get a sense of how much a person is feeling anxious. So while your heart rate is not a direct measure of anxiety, we do know your heart rate goes up when you're anxious. So that could be an indicator of it. And we have other ways of measuring these as well. So the construct itself is the big, broad, abstract concept. We're not going to spend much time in that because we can't measure it. We're going to spend more time in trying to understand those indicators. And that's what we're going to spend most of the rest of this lecture on. Those are captured through variables. The example I have here for you is the weights on the right. A variable is something that is measurable. It has to be able to be measurable, and it can be assigned different values. And so we can assign lots of different weights. We can assign different heights. I'm quite short. Most of you are probably taller than me. Those are all different measures of height. Variables can also be measured, though, as those proxy indicators. So we have measures of anxiety. So you'll see down here, we might not be able to directly measure anxiety with a ruler, but we have a questionnaire called the Competitive State Anxiety Inventory 2, developed back in 1983 by Martins and colleagues. That's an indirect measure of anxiety. And so as your score is higher or lower on the CSAI-2, it tells us whether or not you had higher competitive state anxiety or lower competitive state anxiety. We can also objectively measure things like lower body strength with a 1RM squat. We can measure heart rate directly, and that could be an indirect measure of anxiety. So that's an objective measure, but it could be an indirect indicator. But any of these are variables. And the key piece is that I can measure it, and it can have lots of different values. And so it can be low, it can be high. It might be that it's not that there's an order to it, but they're just different. So like where you're from, some people are from different states in the US, maybe from different countries. That place of your original residence or where you were born, that would be a variable. It's not ranked, but it is something that's there has a different value to it. Some other examples from our fields: cohesion in sports psychology, power, velocity, speed, self-confidence, coping, learning, attention. All of these could be great variables. Again, in order for it to be a variable, though, we have to have developed an agreed upon definition that allows us to measure it and then assign different values to it. So let's get into what different definitions we might see. There are two primary types of definitions. A constitutive definition. These are formal definitions. Historically, these come from a dictionary, but that's not usually what the types of definitions that we're going to use in research studies. We're using technical definitions, often from other researchers, or what we call a constituent. Not that I can pronounce that right. So we might find the definition of what competitive state anxiety is in that paper by Martins. We might find a definition of what cohesion is, the famous authors on there, Karen, Brawley, and Widmeyer, and they define cohesion as the extent to which a group or team stays united towards their objectives. We have these broad definitions that really apply to the construct, or might specifically apply to a technical objective measure like heart rate, where heart rate is defined as beat per minute. But it's a broad definition and can be measured in a bunch of different ways. In particular, though, an operational definition is how you might define a term within the scope of a single study, such as maybe your future thesis or dissertation or independent study or so on. So heart rate, which is defined constitutively as beats per minute, could be measured operationally in a whole bunch of different ways. I want you to pause the video and I want you to think of 3 ways before you unpause. All right, did you do it yet? Okay. If you haven't done it yet, I hope you still do it. If not, let me give you a couple of them. We could do an EKG to get the really specific clinical measurements and get these QRS waves that you're seeing up above. We could do the polar heart rate monitor. And if you have wearables, I have an Apple Watch and that gives me my heart rate. I can use a carotid artery and get my measurement. I can use my radial artery and get my measurement. And if I do either one of those, I could measure my heart or count my heartbeats for over 60 seconds, or I could do it over 10 seconds, multiply by 6, over 15 seconds, multiply by 4, and so on. Lots of different methods I just threw out. Some of them have more accuracy than others, and that's something that as a researcher, you decide what kind of accuracy you need in your operational definition. But for more applied research, like we've talked about earlier this semester, you might be okay to use doing the radial heart rate multiplied by, or count for 6 seconds multiplied by 10. That could be totally fine for you. But if you're doing a really lab-based study with a lot of internal validity, you want basic research, you probably need that EKG or some other better measure of heart rate. So the way that what you choose for your operational definition could vary in a lot of different studies, and it's really based on your research design, your research question, the goals of your study, and so on. Now, we've so far talking about variables. I'm going to go back to talk about variables in a minute, but I'm going to pause really close and identify the term that is the antonym of a variable. If a variable is something that can assign lots of different values, a constant is the opposite. A constant is a measurement that is the same for all participants. So we can't use constant in statistics, but they're really important for us to use in research. And so a constant is something that you're trying to keep the same in your study. Now, a constant is not something that's always a constant. So you might, in your study, just want individuals who are, let's say, 5th graders in your PE class. Well, in that case, you have kept grade constant. In a different study, somebody might be looking at PE classes from K to 12, in which case grade level is a variable. But each study can identify its own host of constants. Another reason, or another thing that we might keep as a constant is the lab setup. So I want the lab to look exactly the same when somebody walks in. I want the temperature and the humidity to be the same when they're performing whatever test or intervention I'm having them do. Maybe before they came to the lab, I want them to eat the exact same food during the 24 hours prior so that they have a constant diet leading into the study, so we don't think food plays a role. Maybe I want all individuals who identify as men to participate in my study, or all individuals who identify as women. When we choose to add constants into our study, it reduces the number of variables. If I reduce the number of variables in my study, that can increase my internal validity, because now I can say it's more due to the intervention I created and not due to these other variables like too much humidity or high temperature in the lab. And so often you'll see more constants in the basic research questions. Now, switching back to variables, because quite honestly, we deal with variables a lot more. There are a couple different types of variables, and this is just scratching the surface. But generally, you can see variables grouped into categorical versus continuous. A categorical is when you have groups and there's no ranking. So people are in groups, and they might be groups for, like I said before, if you are born in the US or born outside of the US. It might be a group for if you are a graduate student or an undergraduate student. It might be what major you're in. So it could be that you're a strength and conditioning student, or sports psych, or physical education, or so on. And so these are often don't have ranking. They might sometimes have ranking, but often don't have ranking, but they are going to separate individuals into different groups. We saw that when we talked about ex post facto research, when we were comparing different groups in a study. A very specific type of categorical variable is called a dichotomous categorical variable. This is when it has to be down to two groups only. And you hear that di as a prefix, meaning two. And so we could have athlete status, being an athlete or not, could be an example of a dichotomous categorical variable. And that's a special case, and it leads us into some special things we can do statistically. So it's helpful to know. Now, if you're not a categorical variable, where you break people into groups, the opposite of that is a continuous variable. This is where you're going to arrange everybody from low to high. You'll often see these presented in histograms, where you're going to be ranked from low to high. Examples of this would be maybe this, or your height, like I would be on the low end, speed, how fast you are on, let's say, a 100-meter dash, level anxiety, how much anxiety you feel before that first exam, low to high, would be all examples of continuous variables. So not groups. Now we can rank your scores somewhere on an axis. Now, this is probably leading us to, and we've already probably said these words a few times, but independent and dependent variables. These are terms I'm guessing you've come across a few different times in your career as they pertain to what we're doing. An independent variable are variables that are classified as independent when the researcher wants to examine their effects on other variables. So usually this is what the researcher brings to the study. They want to look at the impact of their intervention versus a control group. And so that is the independent variable would be the presence of an intervention. The dependent variable is then what you're expecting that intervention to have an effect on. So they're often referred to as an outcome or an effect variable. It's because we're measuring the outcome of the study. It's being measured in response to the presence of the independent variable. So if I'm looking at the impact of an intervention to see if it's going to make me faster, then my outcome is going to be a speed variable. And I am going to be looking to see, is my intervention group faster, have faster speeds than my control group. Now, there are two different types of independent variables over here on the right. The first one you have is an active independent variable. The active independent variable we mentioned before when we were talking about true experimental designs. This is something that the researcher can fully randomly assign. So I can assign you into my intervention group, or I can assign you into a control group. The research or the participant does not bring anything that automatically defines them into one of those groups. So active variables are something we see a lot in definitely true experimental and some quasi-experimental studies. Attribute is when the participant has some form of attribute that you are comparing between in your independent variable. So this could be that you were looking to see the differences between athletes and non-athletes on, let's say, a measure of stress during finals. And so, or a measure of time management. And so if we're looking at those two groups where athlete status is my independent variable, My outcome variable then would be level of stress during finals or time management during finals. And my attribute independent variable, it's because I can't define if you're an athlete or not. I can't randomly assign you into that group. That is an attribute you bring. That would be an example. Those two examples I just said about athlete status with level of stress or time management, that's an example of an ex post facto study. And so we're comparing between multiple groups that I put no control over. I come in at the end and I measure this outcome, but I didn't actually create an intervention or add anything to their environment. All right. So that's it. Those are the things I really want you to know before you come into class. So prior to going to class, watch this. All of this is also on the worksheet that I've posted, so you can review on the worksheet and then complete the variable key term self-quiz before you come to class, just like you would typically do. Make some notes, come up with some examples for your own field. That's going to help you in class. It'll also help you on the quiz. It'll help you in class's activity. We are going to review these examples or other terms for earlier in the semester in class. We're going to have a review activity. So the other thing I'm going to encourage you to review before you come into class, it'll just make your life a little easier, is those research design worksheet. So when you're looking back at the quantitative and qualitative research designs and what's the difference between them, we're thinking now ahead to your first exam. So I want to see if you can get, or we can get you a little prepped in keeping these terms going. It's a lot of terms. All right, thank you. I'll see you soon.